U, by the way, delta U, sorry, specifically, is change in internal energy. W is work. Okay, so how do the signs for these things work? So we've talked about some of them already. We talked about Q. Okay, so for Q, negative if heat leaves. So if heat leaves the object, it's negative for Q. Delta U, we talked about U as well. So negative if internal energy which, let's be honest, is basically based on the temperature, decreases. So if the internal energy decreases or the temperature decreases, then we lose internal energy. Delta U is negative. And then the last one here, W is negative if, let me make sure I get this one right. The question is, okay. So if work is negative if done. Why do I always have a hard time remembering this one? That's empty. So if it's done, work is negative if done by the object. Oh, sorry. Nope. This one I can never keep straight. Work is done on the object. Work is negative is done on the object. Think of it this way. You don't like it when your parents tell you what to do. So any work they make you do that they do to you, you're negative about. Just disagree. Okay, so let's take a look at this because there is some math to do here, but it's really pretty straightforward. You just got to be really careful about the signs. Okay, so number 8 here. An ideal gas expands without temperature changing, performing 3.4 times 10 to the third joules of work in the process. How much work does its internal energy change and how much heat is absorbed? Okay, temperature does not change. So delta T is 0. Temperature is directly related to the internal energy. So if the temperature doesn't change, the internal energy doesn't change. So by how much does the internal energy change? 0. Okay, so we do 3.4 times 10 to the third joules of work. So we have 0 for the internal energy change. Okay, plus 3.4 times 10 to the third joules. Okay, the gas is doing the work, so it's positive. Okay, work done by is going to be positive. So how much heat is absorbed? Well, in this case, we're releasing the heat in order to do the work. So I had it worded a little wrong. But if we're solving for Q, Q would just be that value. So this heat is coming in, right? Sorry, I had it right. Positive Q, heat comes in. Negative Q, heat leaves. So this is positive because we're absorbing this much heat in the process. In order to keep the temperature the same, we have to absorb heat to do work. Okay? If we didn't absorb the heat, then the temperature would change in order to do the work. We would have a decrease in temperature in order to do the work on something. So if the temperature didn't change, then the amount of work that we do, we're having to absorb heat in order to do that. All right, just 2 more for you guys to do. In a perfect car engine, ideal gas is compressed by half its volume without any heat being transferred in or out of the system. In doing so, 1,850 joules of work is done on the gas. By how much does its internal energy change? So be careful on the wording. Be careful about directions. See what you can figure out there. And then 10. Gas in a combustion engine expands, lowering its temperature. So as it expands, it cools off. What happens to its internal energy? And then if the internal energy decreases by 10 joules, and 8 joules of heat is transferred into the environment, so out of the gas into the environment, how much work is done, and is it done on or by the gas? So see what you can do on that one. I'll give you time to just finish up 9 and 10. That's all you got left to do. And then we'll talk about the review guide. And give you time to work.